Hello again, I'm Ben Canning. This is an outro to Newton's first law, or the collection on Newton's first law. As always, you need 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and your follow-up questions on Google Forms. So the big idea we were working towards, or have been working towards, this idea of how does force affect motion. And in this unit, and really kind of lately, we've been looking at a special case of Newton's second law, dealing with zero net force, or a lack of force, rather than the presence of force. It might seem like we're kind of going backwards, but it's really just kind of figuring out things that we had studied before about constant velocity and kind of re-looking at them with the lens of forces in mind. The unit focus was we were going to be looking at two things: Newton's first law, which is a special case of Newton's second law, and then we're also going to look at Newton's third law and action-reaction pairs. Well, we just discovered that Newton's first law is actually the special case of the second law, where if F equals ma and a equals 0, then we get a net force of 0 in this case. Or vice versa. If the net force is 0, we know the acceleration is 0. And so we just focused on that in this collection. And now it's time to move on to Newton's third law, or action-reaction pairs. So the collection, like I mentioned, we really unpacked the concepts and ideas around the first law, hopefully so that you don't have things like this happen to you. And so now that we've really kind of unpacked the first law and its implications in the real world, it's time that, again, like I said, we move on to Newton's third law and look at action-reaction pairs. So 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and please do your follow-up questions on Google Forms.